So in this case, we are going to continue with our revision of the November 2025 exam for our electrotechnics, and for which is question number 2 on DC machines. So 2.1, you're given by means of load characteristics. How is a compound DC what generator described? A compound DC generator. You must take note about that. So the characteristic of a compound wound DC generator is given in this format where we've got our terminal voltage, the load current. So we are going to have conditions of under compounded, the level compounded, and this is where you have the desired voltage. From here in a straight line, you have got your desired voltage, then over compounded. So that is the diagram that they just wanted you to illustrate. So remember your characteristics for each and every type of your generators and also the motors. They can ask that one, right? So this is part of your theory and diagrams. Make sure that you go through that part, all right? And the properties that you're having when you are referring to a compound wound generator, all right, of which in this case we are not going to dwell much into that. Mostly they're going to ask on the diagram. So just know the levels that you have from this terminal voltage. On the upper, it's over damped. Then under damped is the one that is below, the one that is in the lowest level. Then the level compounded is the one that is from this desired, the one that goes here, gives us the level. So just go through that. And 2.2, you were given the armature of an 8 pole. All right. So take note what you are working with. The armature of an 8 pole 25 kilowatt series motor. It's a motor that you're working with. So when you're given the power, a 10 kilowatt, a 20 kilowatt, that power that you're given represents the output. Remember, I explained about that. So this is your output power, 25 kilowatt. And on a motor, we know that this power is what mechanical. The output is our mechanical, whereas the input is electrical. So they said that's an 8 pole. So we can find the pair poles 8 over 2, which is what? 4 pairs. And the voltage is given, which is 450. And we are also given, and here's a total of 32 armature slots. The number of slots is what? 32. The motor operates at a full load efficiency of 85%. So there is a need of us having efficiency since we are given the output power, which is mechanical. We are supposed to work with electrical power. So we are supposed to use what? Efficiency to determine the input power, which is what? Electrical. And it runs at this speed of 950 revs per watt per minute. The resistances of the armature and series field are given. All right, so we've got the resistances on our circuit, on our uh, series motor. There's the resistance of the armature first, 0.3 ohms, and that one of the series 0.25. This is of the series 0.25 ohms, since we are given respectively. Calculate the possible number of armature conductors per watt per slot. So we are supposed to determine armature conductors per watt per slot. If the useful flux is given, all right, so we have got the useful flux per pole, 32 milliwebers, and the total brush contact resistance. So we also have the resistance of the brush, 0.15 ohms. All right. So how can we calculate this Z, which is the Z per slot, the number of conductors per watt per slot. This can be calculated if we have the generated EMF, which in our case, we are dealing with a motor. So this is a series motor, remember? So it remains, we'll be having it as the back EMF, all right? So we're going to have something of this nature, the series field. Then here we're going to have our armature, all right? So that is the condition where here this is the input. It draws in current, it takes in current from the supply. So the arrow is supposed to be facing inside. It's a motor, remember? So that's the load current, which is equal to the armature current since it's a series circuit that we have. The voltage and the power at the input, and at the output we are going to have this one as what, as our output, where the power is what, mechanical power, the output there. Then we have got the armature and the series field. So this circuit of the series motor was going to help us to determine that big EMF, which is the generated EMF, which is needed to determine Z. Since we do understand that E is equal to 2 times the flux, the useful flux, we need N, the speed, the pair poles, the number of armature conductors over what, 60C. C is supposed to be given here is what, wave wound. So C is equal to 2 for a wave. For a lap, you multiply by what? By P, the pair poles. So that is, we are given this one as a wave. So our C is what, is 2. All right. So you look into the formula because here we need to find what? Z, so that we can find Z per slot. So we do not have, we need to calculate this Z. On this formula, we do not have this generated EMF, which is our back EMF for a motor. The useful flux is given. Our N, the speed is there. The pair poles, we have it. C, we have. So everything we are given, each and every part here. So what we need is to find E first. And this E is taken from this series motor that we are given. Remember that it is what? The back EMF. The back EMF, all right? Which we can consider as part of our formula sheet here. This is direct current machines for a motor. This is what we have, V minus armature current times, here supposed to be RAC, resistance of the armature circuit, where the armature current is flowing. All right, where the armature current is flowing, we are dealing with the motor, remember. So back EMF is equal to V minus armature current times the resistance of the armature circuit. So the armature circuit now is where this armature current is flowing. The armature current is going to flow through the series and also through the armature. So it is covering that. So meaning to say the resistance of the armature circuit is going to be the combination of the series. All right, let's start with the armature plus the series. All right, and also the brush is affected on this part. So this is what we are going to have as the resistance of what? The armature circuit. All right. So meaning to say our E was going to be equal to V minus armature current into this part, RA plus the series plus the what? The brush. Just like that. So are we having everything? We are only given these resistances and the voltage. If you take note here, they gave us the resistances and the voltage. We have it on the supply, but we do not have the armature current. So you see, guys, we are limited. We do not have what? The armature current. And the armature current, in order for us to have the armature current, we must have the input power. So from the efficiency, there is no way we are supposed to determine the input power. So you see these steps, guys, you must go through. That's why I say it is 14 marks. You need what? The input power, so that we can have the current. And input power from efficiency P out over Pn. So that's Pn is going to be divide is going to be P out over efficiency. Output power, which is our mechanical, 25 kilowatt. All right, over what? Our efficiency as a decimal, that will be 0.85. 0.85. So we have got the input power in kilowatts. So we're going to have our input power in what? In kilowatts from this calculation. And that was going to be 29,412 kilowatts. So we have the electrical power. This is our electrical power, the one that we can use voltage and current. We cannot determine it from the mechanical. Remember, output is mechanical, this one. So thus, we can determine the current now, which is the same as the armature current since they are in what? In series. So the load current from power and voltage is simply input power over V in. And this is the same as what? Our armature current. So therefore, our armature current was what? Input power 29,412 times 10 to the exponent of 3 over the voltage at the input, which is what? 450 volts. So this is 450 what? 450 volts. So that is the idea, guys, just like that. So you have the armature current, which is the same as the what? As the load current of 65,36 amperes. And this is the one that you were going to need in the calculation of what? The back EMF. Here we need what? The armature current. So let us substitute our back EMF. That's the V, 450 minus, we calculated the armature current, 65,36 into what? The resistances of the armature, this and that as we are given. So the armature is what? 0,3. Just add these three, all of them as they are. All of them. So that was 0,3 for the armature plus 0,25 plus 0,15. So you add them, then simplify this. You are having what? The back EMF. That's 404, what? 248 volts. Remember, I say the reason why we need this is so that we can determine Z here, the one that we are asked. So we are not having E. Now that we have got E, let us find what? Let us find our Z. So Z is equal to what? That's making the subject of the formula. Gonna cross multiply. So Z is gonna be equal to 60C times what? Times E over this. You're going to divide by 2 flux NP. So we now have this E. So we can find our Z. All right, let's substitute 60 times C. Remember, we have got everything here there. Our C is 2. All right, our E, the back EMF, the generated EMF of what? 404 point what? 248. So that's it. Just like that. 404, what? 248. Everything over 2 times the useful flux. We have got everything. 32 milliwebers. So that's times 10 to the exponent of minus 3 times N. Remember, we've got the 60, so our N must be in revs per minute. 950 times P, which is the pair pose, which is what? Which is 4. Just like that. So that's our conductors, armature conductors. This was going to give us a decimal, all right? It was going to give us 199,464 conductors. So you round up to the next whole number, which is going to be what? 200. So this is going to approximate to 200 what? Conductors. Is it our question? No. The question is we must find the number of these armature conductors per what? Per slot. For 32 what? For 32 slots. Given the number of slots that there are, 32 slots. what is going to be the armature conductors per what? Per slot, per each. Simply divide. So that's 200 conductors over 32 slots. And that was going to give us 6,25. That's the number of conductors per slot. But we have to round up, all right, for these values. So to the next whole number, that's 7. So it's going to approximate to 7 what? Conductors per what? Per slot. Answer the question. The question is not about the armature conductors, no, but the armature conductors per what? Per slot. So you must divide by the number of slots at the end. So you see, it's a repetition. Nothing is new on this question. We have done each and every part. So please do revise the basics, all right? Just work on your basics. So that is it, guys. Till we meet again.